Hi and welcome to lesson of multivariable calculus. So in today's class, we are going to discuss about traces of the surfaces. So previously we saw how to find equation of straight lines and planes in three-dimensional coordinate system. And we also worked on some problems related to the orthogonal and parallel planes and their intersection and the lines of intersection of the planes. Now, let us consider an equation of a plane is given, that is 4x plus 2y plus 3z equals to 12. Now to find a trace of the plane in the axis, what we need to do is that we need to see how the projections of that plane look like on the projection of the given plane look like on the plane that it is projecting. So this is z-axis, this is x-axis, and this is y-axis. Now we know that this plane here, this is zy plane, and this plane is xy plane. And here, if we see this one, here is this zx plane, right? So these are the planes xy, y, z, and zx plane, right? So now we have to see that how to draw the trace of a surface in these planes. Now, beginning with this example, since we are given with equation of the plane in 3D, so to find the trace on xy plane, what we need is we need to put z equals to 0, right? So when we put z equals to 0, we will get an equation of the form 4x plus 2y equals to 12, which represents equation of a straight line in xy Cartesian coordinate system, right? So if this is the plane, this is the xyz three-dimension Cartesian coordinates. So now we can see here that 4x plus 2y equals to 12 is a line on xy plane. So we can draw it on xy plane since we have the equation in terms of x and y. So we can compare with it the mx plus c, right? Y equals to mx plus c, where c is the intercept, y-intercept. So first of all, we need to convert this equation into a standard form by just simply manipulating the variables. So it is y equals to negative 2x plus 6. Now this line, we can say that this is actually a line whose y-intercept is 6. So let's say that this is its y-intercept at 6. And its x-intercept will be putting y equals to 0, we will get x equals 6 over 2, that is 3. So we will get something here, right? Now, since it is a straight line, so we can join these 2 points with this straight line. So this is the trace of this plane on xy plane, right? Similarly, now we need to find the trace of this plane on yz plane. So now we need to put x equals to 0 to find the trace on yz plane. So we will get this equation 2y plus 3z equals to 12, which is nothing but again an equation of a straight line. So we can find the points on z and y axis by plugging y and z 0 respectively. So if we put y equals 0, we'll get z equals to 4. So this point will be somewhere here. And if we put z equals to 0, we will get y equals to 6. So again, this point is already marked here. So it will be a straight line joining these 2 points like this, right? And again, to find its trace on zx plane, we'll put y equals to 0. So this term will be 0, and we'll get 4x plus 3z equals to 12. Now solving this line for the intercepts, we can get z equals to 4 and x equals to 3. So these points are already marked here, so we can join these 2 points simply by a straight line. So this will be the surface, or we can say this is the plane that of which we are given the equation. So this is the plane that we need to draw. So we can draw these planes using the traces. Earlier we did it using the intercept forms by finding the intercepts, and it is somewhat similar to that, right? Now let us move to another example. So in this picture you can see that this is how we find the traces, right? Now see this example. So it's like a cylinder, right? But it's open here. It's like we can say that if we want to bend a paper, right? Or if we like we make a curve using the paper, it's a curved paper, right? It's like this. So it's simply the trace. Uh, its trace on XY plane is nothing but parabola, right? So it's a parabola. We can see here, this is the trace on XY plane, and this is a trace on the ZY plane, right? So it's in, sorry, it's not in a ZY plane, but it is extended in the Z direction. So it's also parallel to XY plane. So it's parallel to XY plane, right? So we can just draw this like this by making a parabola here and then a parabola here, right? And then just joining the ends to make the surface, right? Like this. And okay, so it's like this, right? So this is like a curved paper, right? So it's a surface like this. Okay, now see one more example. Now this is equation of a parabola again, that is y equals to x squared minus 4, and we already know how to sketch this on xy plane since it's xy plane. So we know that for y equals to x squared, it's a parabola, right? Whose this point it goes through the origin, and this one it will just be like, since it's x squared minus 4, so it will shift 4 units down like this in the xy plane, right? So it will be shifted like this. But we know that we have to draw this in three-dimensional system. So the equation is of parabola in xy coordinate system. So we can say that the z dimension is free, right? So this figure will be extended in the z dimension. So if we can draw the figure here, like we can see here that if we have this three-dimensional coordinate system like this, x, y, and z. So we have a parabola that is y equals to x squared minus 4, which means that we will have a parabola in xy plane. So it will be like this and shifted 4 units in the negative direction. So it will look like this. And now since we have to extend this in the z direction, because z dimension is as a free dimension, so it will be extended in the z dimension. So it will look like this. So we can extend this in this manner, and from here we have this. Now just join this point here like this, and it will come here, right? And join it with this. Now this is a para, parabola that is stretched in the z direction, right? So we can color it like this. Okay, so it's a parabola in xy plane, and it's stretched in the z direction, since the equation suggests that the parabola is in xy plane and z is the free dimension, right? Now again, we can take a look at another example. For instance, we are given this surface, that is z equals to x squared plus y squared, right? Now we are familiar with this equation. Actually, this is the equation of circle. We know that x squared plus y squared equals to r squared. And now if we want to find the trace of this surface, so what we need to do is that we need to neglect one of the variable first. That is, let's say we can neglect y square, and we want to look for this equation only, z equals to x square. So it's a parabola in zx plane, so it will look like this. We can draw it here on xyz Cartesian system. So it will be like, this is x, this is y, this is z. So this is negative y, this is negative x. Now this is z equals to x squared, so it will be on this zx plane like this. It will be like this, right? We can join this here just to make it clear that it is in zx plane, right? So it's the parabola that is z equals to x squared. Now this is the trace of this uh, surface on zx plane. Now for the trace of this surface on the zy plane, because if we neglect this x square, now we'll get z square equals to y squared. Now this will be somewhat like this. This is x, this is y, this is z. Since this is z equals to y squared, so the parabola will be like this. All right. Simply it will be like this. So this is z equals to y squared, right? Now if we combine, if we want to draw these two parabolas combinedly, now we will see that what surface we are going to get. So let us draw here. So this is the coordinate system. This is x, this is y, this is z, and we already have drawn this earlier. That is z equals to x square. So it was like this. Z equals to x square like this, right? And z equals to y squared, it will look like this, right? Passing through the origin. So let's make it more clear. So it will be like this. All right, now we just need to uh, draw it. We need to make some more drawings on it. And if we join these like this, we will get a surface called a paraboloid, right? Like this. It's not clear. It will be somewhat like this. And we can just oh, this we have to draw it again. Okay, so this is z-axis, y-axis, and x-axis. Now I'll draw it directly. So we have this in this one, right? So if I draw it like this, it's easier to draw it like this. Right now we can see that this looks like a paraboloid, right? So we can just color it like this. So this surface is called a paraboloid, right? So this is how we can draw this surface. Z equals to x squared plus y squared, right? Now move on to the next example. Okay, you can see here it's a clear picture. These are the traces, YZ trace, and this is ZY trace. This is the YZ trace, sorry, this is XZ trace, and this is the parabola by combining these traces, right? So we will see some more examples. Now see here, the equation is y squared over 4 plus z squared over 9 equals to 1. Now you are familiar with this equation. This is equation of the ellipse, right? But this ellipse is in YZ plane, okay? So again, if this is in YZ plane, it means that the X dimension is free. So we will find its trace on YZ plane, and then we will just simply stretch it in the X direction. So this is X, this is Z, and this is Y. Now this is the ellipse and the YZ plane. So it will be, let's say it's in YZ plane. So let me draw negative Y plane as well. So this is the negative Y plane, or let's make more clear. So it's like this, right? Now the ellipse here will be, so its major axis is on along the z-axis, since z is square over 9. So it will look like this. This is the ellipse on zy plane. Now this needs to be stretched in the x direction like this, because uh, we already established that this ellipse is in YZ plane, so x dimension is free, so it will be stretched in this dimension like this, x dimension, right? So we can make an ellipse here like this. Okay, it's not as good as it should be, but you can just imagine that it's a cylinder. It's a cylinder having the cross section, elliptical cross section, right? Cylinder with elliptical cross section. So this is how we draw the surfaces in three-dimensional system. Now here's one more example, that is z equals to cos x. Again, we know that how to draw this function, that is cosine function. So let us consider y equals to cos x on xy plane. So we know that it looks like this. It looks like this. Okay, it looks like this. It's periodic, right? It will be like this. Okay. Now, if it is z equals to cos x, so this will be the similar thing, but in the zx plane, right? So in the zx plane, we can see here that uh, the curve look like this. So it look like this. Okay, this. So this is, and this will go on and on this zx plane, right? And now similarly, the variable y is absent here. It means that it will be stretched in the y direction. So we need to stretch it in the y direction. So we simply, what we do is we just stretch it like this. The same cross section will be here, and the same thing here. So it's z equals to cos x. So this is the function. Uh, this is the surface of this given function, z equals to cos x. So this is how we can construct these surfaces, right? So the next lesson is quadratic surfaces, but we'll start this in the next class. So that's all for the time being. Thanks for watching the lesson. Goodbye.